Hello, everyone, and welcome to Jack's Math Notebook. This is our second video as relates to how to compute the compound interest. And so we're going to compound annually, and then we're going to compound quarterly. And let's take a look at our first example in which we have Rhonda puts $2,500 into an account that pays 6% interest compounded annually. And we're going to use this formula in which we have A is equal to P times a quantity of 1 plus R raised to the T. And if you remember, A equals amount, R equals rate, P equals time, and P equals principal. And so what we're going to do, we're just going to plug in all this information right here. So we have R is equal to 0.06, T is equal to 10 years, and P, which is the principal, is equal to $2,500. And let's go ahead and plug everything into this formula like we did right here. And if you plug it in and compute it, you will get this. You will get 2,500 times the quantity of 1.06 raised to the 10. Okay, and so this time we're doing it for 10 years, and we're going to see what we get when we do that. And when you plug that into your calculator, you're going to get a new amount of $4,477.12. Now, what if we take that 2,500 and we compute it for 20 years? And let's see what happens to our amount when we go 20 years into the future. And so when we go 2,500 times the quantity of 1.06 raised to the 20th power, our new answer is going to be $8,017.84. And that's what happens if you just keep $2,500 in your account for 20 years. Imagine that. And let's go to compounded quarterly. And so we have, remember our formula from last time, A is equal to P times the quantity of 1 plus R divided by the number of times, okay, to the number of times to the T. So we had that right there. And so Rhonda puts $2,500 into an account that pays 6% interest compounded quarterly. And quarterly means 4 times. And so what we're going to do here, we're just going to rewrite it like this. Our amount is going to equal to 2,500 times the quantity of 1 plus the 1 plus 0.06 divided by 4. And then we're going to use that 4 and put it over here and multiply it with the time. And so that's going to be 40 when we do go right here. And so when we do this division and then add it to the 1, here's what we have. We have $2,500 times 1.015 raised to the 40th power. And our new amount, our answer is going to be 4,535.05. And let us compare this amount to this amount. And right here, when we compound that amount quarterly, we get a slightly higher amount right here. See, 4,535, okay, and 5 cents. And here in this case, we get 4,477.12. And so let's see what happens when we do this amount and we raise it to the 4 times the 20. Remember, we're doing 20 years here. Let's see what happens when we do it over here. And so we have 4 times 20. That would give us raised to the 80th power. Yes, you can do that in your calculator. Don't worry about it. And so now we have $2,500 times a quantity of 1.015 raised to the 4 times the 20. And when we do that right here, we have $2,500 times a quantity of 1.015 raised to the 80th power. And when you plug that in, you will get $8,226.66. And if you notice, this amount is slightly higher than this amount right here. So compounding, let's say semi-annually or quarterly, you will just get a slightly higher amount when you compound annually. You have received a lot of information. I wouldn't blame you if you need to pause this video and just kind of give everything a once over or replay this video as many times you need to gain a deeper understanding of what it means to use compound interest annually and quarterly. And with that in mind, please comment, share, like, and subscribe to Jack's Math Notebook for more content. Thank you and goodbye.